Today's class is very important on the point of the Kirchhoff's law, and this is a very complicated solution, and this solution needs a lot of patience, and I will show you as far as possible the technique how to solve out this one. You try to solve out this one. This type of question is very often asked in entrance exam, and class exams also in board and CBSE board. And here this is diagram where you are asked to find the current in each resistances and equivalent resistance of the circuit. This is very tough because in any other combinations of equivalent or parallel way you can't arrange this one because it is very difficult. So in this way you can solve this one. So first of all, there is no direction of nothing is given. Let me first assume the direction of the current I is equal to in this direction from negative to positive. I have assumed this one. And when this current I has entered this point, this say this is C and this is D and this is A and this is B. Am I right? So first second, when current enters in this way here, this splits into two parts. Say this is I1 and this is I2. And whenever is come to this junction, this transform changes its direction. Say it is I3, and another part has come to this one, say I4, and this has come in this way, this has come in this way, and this will come in this direction. Say this is I5. Am I right? These are the direction. I will show the technique minutely, follow the class. But one thing here, the direction of current I3 is only assumption, may be correct or may not be correct. That can be evaluated on finding out the value of I3. If it is minus, our assumed direction is wrong, and if it is plus, our assumed direction is correct. So let us go through as per our direction, which I have shown in the figure, the direction. So let's start with junction rule. Now, what is junction rule? Especially at junction rule, and whenever this current comes in this way, it comes in this direction. The current comes in this direction. So this is again I. So junction rule at C, I have written at C. At C, what's happened? When you see the C, then this current I enters and these two leaves. Leaves means minus, enter means plus. That is I is equal to I1 plus I2. Am I right? And if you consider the point A, junction A, where this enters and these two leave. So I1 is equal to, this enters positive and these two leaves is negative, means I1 minus I3 minus I4 equal to 0. That is I1 is equal to I3 plus I4. I3 plus I4. At this point, let me add something. Later on, I will tell you I4 equal to I1 minus I3. I will tell it a bit later. Now, at point B, what is point B? Come to this point B. At point B, this is the current entering and this is current I3 entering. Am I right? So both two currents are entering and one is leaving. So entering current is plus, I2 plus I3 is equal to I5. Am I right? So I can write I5 is equal to I2 plus I3. Here also I am circling the value. Later on you can understand. So next point is D. So when you come to D, D means current I is coming out and two current entering, I4 and I5. So I4 and I5 is equal to I. That is I is equal to I4 plus I5. So this is all about the junction rule. So now the more complicated thing is the loop rule. So loop rule, let us consider this point. From this point, that is from battery cell, the current is moving. This is source. We have assuming this source. Say that point P, this is coming to this direction, and it is coming in this direction. It is coming in this direction and coming in this direction. So we can say this is in this way. Am I right? Am I right? This is loop 1. So let us write loop 1. So what about loop 1? Loop 1 means the current is leaving a bit. Earlier classes I have mentioned that for EMF, when voltage drops, when from the cell current is coming, that is from negative to positive. If it is starting from negative, positive, answer is positive. You assume is positive. So 13 is positive. It comes in this direction, it comes in this way. So the current is along the 1 ampere resistance. So 1 into I equal to I into current equal to V. I1. Again here it is coming here this point and coming out this one along the direction of the resistance. So I4 into 1, V is equal to IR, voltage drop is equal to I4, and it is coming to this means this part is 0. When it means this means 0, potential is 0. So total is 0. So this is the first loop 1. So from this loop you will do one thing. So 13 is equal to I1 plus I4. We need to find out I1, I2 and I3, 3. Am I right? 3 unknown quantities. So we will just try to replace this and replace this. 1, 2, 3 is needed. So we will try to, this is our target and this is the technique. So I4, what is I4? I4 equal to I1 minus I3. So you write here 13 is equal to I1 plus I4 is equal to I1 minus I3. Am I right? This is equal to 0. So what we get is 13. Am I right? Say this is 1. So come to the loop 2. Let us choose loop 2. What is loop 2? Loop 2 is the current is coming out from this point. Am I right? And going in this direction, in this direction, in this, all are outward, 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 and coming in this direction and reach that point. This is loop 1, and loop 2 is, say current is coming in this direction, enters and goes in this direction, in outward direction, outward direction, outward direction, and come to meet at this point. Am I right? This is loop number 2. So here loop 2 gives what is again current is leaving from the cell from minus to plus. Am I right? So minus to plus means this is 13 is positive, and when it enters here, again the direction, the current passes through the direction of the resistance, in the same direction of the resistance. So I2 into I equal to potential difference, and potential difference is drops. So when it enters, it is minus. So I2 into 1 means Vi is equal to I2. 13 minus I2, and it comes to that point. Again it comes in this direction, again along the direction of the 2. Am I right? So 2 into V, I into V, I equal to voltage drop, twice minus twice I 5. Now it comes to this point and come out. So from this point to that point, nothing is there. So when it meet that point P, so you are getting 0. So loop rule 1 and 2 is with respect to point P. Am I right? So here we need to do something, means we will replace I5. These things you should keep in your mind is 13 minus I2 minus 2. What is I5? And now let us find out I5. I5 is equal to I2 plus I3. I5 is equal to I2 plus I3. So here you write I2 plus I3 is equal to 0. So we get here is, again you see here, yes, we are getting this as 2. Now we will not finalizing this equation because I need to do something here. A bit later you will find out. Loop 3. What is loop 3? What is loop 3? Loop 3 is with respect to point C. With respect to point C. If you assume here, we will just consider this point as loop 3. It starts in this way, enters and goes. This is loop 3. This is loop 3. So in loop 3, if you again use Kirchhoff's law, so the current is entering in this direction. So this is minus I into this, minus I1, and again this is entering in this direction, minus I3, I into B equal to minus I3. This is entering in the opposite direction, currents coming in this direction and coming to this direction. Am I right? This is starting from this, comes in this direction, goes this direction. So with respect of this, I2 is plus I2 into 1. Am I right? Here you are getting I2 is equal to I1 plus I3. I am encircling this because the third rule, I will apply this third rule here. So here we get thrice, in place of I2 we will write I1 plus I3 plus twice I3 is equal to 13 is equal to thrice I1 plus thrice I3 and twice I3 equal to 5. I3 is equal to 13. Now you give it 2. Am I right? So then you can use it here 3. You can use inside this using equation 3. Am I right? We get this one. So from 1 and 2 we see 13 and 13 are equal, and the term I1, I1, I3, I3, there is a possibility solving out to get the answer. So what we do, I will not show the trick, show the technique. Here this is 5. Am I right? 5 I3. So if equation 1 by 5, so that I3 will be 5. So if on this, so 5 by 3 and 5 by 3 will cancel, or 5 is a 65. On solving out 2 and 1, from 2 and 1 we get I1 is equal to 6 ampere. I am not showing, it is very simple calculation. So now if I1 is equal to 6 ampere, if I1 is equal to 6 ampere, so if you put this value here, 6 into 2, putting 6 ampere is equal to I1 in 1. What we get? 2, 6 is 12, I3 and 13. So we get I3 is equal to minus 1 ampere. The fact lies here. We get I1 is equal to 6 ampere and I3 is equal to minus 1. So current is minus, means simple, nothing to do. You just reverse the direction. Our assumed direction is wrong. It should be in this direction. Am I right? So let us keep earlier direction. Just will show the correct direction in this way. This is the meaning. Am I right? Now again from I2 is equal to I1 plus I3. From 3, what we get? I2 is equal to I1 plus I3, 6 minus 1 is equal to 5a. So all the way it should be plus. On direction the matter, the result has come as this one. We have got I1, I2, I3. Our first purpose is solved, that is current in each resistance. Now we are coming to the next part, is to find out equivalent resistance of the circuit. Equivalent resistance of the circuit. All the resistance should be calculated out. So what we say, in a very simple way, if I draw without showing the resistance, just in a very simplified manner, if I draw, this is C and this is D, this is A and this is B, and this is 6 ampere, that was I1, and this is I2, 5 ampere, that one I2. Am I right? So no need to calculate in this way. Earlier you put the value, you need not to get this one. What's happened? That direction was in this way and that direction was in this way, and that direction, as per our correct direction from the sign convention, we get that direction is 1. So if current I1 means since 6 ampere come this one, so this 6 ampere along with this current, and what was that current? That one is R3. So R3 is equal to what? R3 is 1 ampere. R3 is equal to 1, sorry, I3 is equal to 1 ampere. So 6 ampere is coming and 1 ampere is coming, you are getting 7 ampere. Am I right? And here what's happened? It is coming to this one. So if this coming into this one, so this is 5 ampere, and this 5 amperes, this is in opposite direction. 1 ampere is coming in this direction, 4 ampere is coming in this direction. So you see the beauty of the solution of this Kirchhoff's circuit is circuit is there. In the above circuit there is 6 and 5, 11 ampere current, and below there is 11 ampere current. Am I right? So we can say that if we simplify this in this way, and all these resistances are made in this way, and if you write this resistance is whatever way they are arranged, this is resistance equivalent. We need to calculate what is equivalent resistance. So we can say the current is nothing but 11 ampere, and the your voltage source is 13V, EMF is this. So again what we tell is that if we assume the Loops law of Kirchhoff's rule, Loops law, so current is following in this direction, flowing in this direction. Am I right? So what's happened? It is minus and it is plus, that is minus to plus, you assume this V value positive, and it is entering into the solution along the resistances which are equivalent. So this is minus R equivalent, and that too must coming and enters here, starts here and coming here, and coming here. It's according to this, it is equal to this. And here, sorry, that should be I into R. Voltage drop in along enters, current enters in the direction of the resistance, equivalent resistances. We need to find out this, and it is drop of voltage equal to minus R, and that if you solve this, it is 13 minus what is I is equal to 11, and R is equal to, we don't know, R equivalent equal to 0, therefore R equivalent is equal to 13 by 11 equal to 1 point like this. Am I right? So this is all about the class. And another valuable conception and critical videos on Kirchhoff's law and Western bridge will be provided, and you please follow the end screen of my today's video.